Limits actually appear in many math problems, but the term limit was never used. If you're an algebra student, then you probably have heard of end behaviors or asymptotes. So what's a limit? Say you have a linear equation, y is equal to 2x plus 3. We can see that as x approaches infinity, y also approaches infinity. A good way to see this is if you plug in some very large value for x, such as 1 billion, you can see 2 times 1 billion, 2 billion plus 3, so 2 billion 3, is also a very large number. Say we plug in a trillion or centillion, y will also start to follow that pattern of approaching infinity. So in the notation in calculus, we use lim, and then our actual limit, x approaches some value s. And then we have some function right here. And this is all a limit consists of. The lim written out, the actual limit itself, and the function. Okay, so here we have our limit. X approaches 4, and then we have our expression x plus 2 over x plus 3. So it makes sense that if x approaches 4, it gets very, very, very close to 4, such as 3.9999999. That's very close to 4. So I think it's safe to say we can just plug in 4 for x. And we should get 4 plus 2 over 4 plus 3, which is equal to 6/7. And this is the answer to this limit. This method is called direct substitution, where we directly substitute x, or the variable in our expression, with the actual limit itself, the number that x is approaching. Okay, so here we have the exact same equation, except now x is approaching infinity. Now we'll use direct substitution again. We should get infinity plus 2 over infinity plus 3. Okay, well, we don't have a value for infinity. There's no value for infinity. Say we just substitute infinity with a very large number, such as a billion. A billion plus 2 over a billion plus 3. The larger that our x value gets, so say it's a number as significant as a billion, the 2 and the 3 starts to get insignificant, because you cannot compare 2 with 1 billion. The larger that x gets, once it approaches infinity, the 2 and the 3 become insignificant, and we're just left with 1. So here's our limit. Lim x approaches 5, x squared minus 3x minus 10 over x minus 5. Let's just use direct substitution. 5 squared minus 3 times 5 minus 10 over 5 minus 5. Oh wait, we can't do that because the denominator just cancels out to 0. Now what do? We can't use direct substitution. Well, not yet. Let's rewrite our limit, but we're gonna factor out the numerator this time. Lim x approaches 5. What multiplies to negative 10 and adds to negative 3? X minus 5 times x plus 2 just expands to this, because negative 5 times 2 is negative 10, negative 5 plus 2 is negative 3, and our denominator remains the same. Okay, we can cancel out stuff now. This cancels out, so we're just left with x plus 2. So limit x approaches 5, x plus 2. Yeah, I think we could just move this 5 into the x. This is just equal to 5 plus 2, which is equal to 7. So here's our limit. We saw that we cannot just plug in 3 for x in the previous problem. We cannot use direct substitution here, so let's factor out the numerator. So what multiplies to 5 and adds to 8? Oh wait, that's not factorable. What do we do now? We can't use direct substitution, we cannot simplify this. What is asymptote? What does this limit mean? as x approaches 3. Okay, well this could approach 3 in two directions. Either it can start off from some really large value and go down to 3, or it can start off with a really low value and go up to 3. So let's look at numbers very, very close to 3, such as 2.9 or 3.1. So we'll just substitute 3.1 into this x. We should get 3.1 squared plus 8 times 3.1 plus 5 over 3.1 minus 3. Okay, well the numerator just simplifies to 39.41. The denominator is just 0.1. So this just becomes 394.1. Now we'll plug in 2.9. I'll do it in pink here. 2.9 squared plus 8 times 2.9 plus 5 over 2.9 minus 3. The numerator is definitely a positive number, so we'll say positive number, but the denominator is negative 0.1, a negative number. So this is going to be a negative number. Okay, well, when we plugged in 3.1, why did we get a positive number? But when we plug in 2.9, we get a negative number. They're opposites. This means that this limit does not exist. Okay, well, we cannot just use direct substitution, plug in a negative 3. That does not work. So let's factor out the numerator. This just becomes lim x approaches negative 3, x plus 3 times x minus 1, all over x plus 3. We can see that x plus 3 cancels out. We're left with lim x approaches negative 3, and then expression is x minus 1. Now we can use direct substitution, and this is just negative 3 minus 1 is equal to negative 4. It looks like we can just use direct substitution here. This just simplifies to 2 times sine pi over 2 minus 3 cosine pi over 2 over pi over 2. Okay, well, what's sine pi over 2? Sine pi over 2 is equal to 1. We're multiplying this by 2 minus 3 times cosine pi over 2 is just 0, all over pi over 2. This is just equal to 2 times 1, which is just 2, minus 3 times 0, which is just 0, over pi over 2, which is equal to 2 over pi over 2, which is equal to 4 over pi. Okay, looks like we cannot use direct substitution because the denominator cancels out to 0 again. And we have 2 fractions in the numerator. How do we do this? We usually try to find a common denominator. And a common denominator is usually found by multiplying both denominators together. In this case, we just get 4x. So let's multiply top and bottom of this fraction by 4x. We just get 4x times 2 over x minus 1/4 over 4x times x minus 8. Let's simplify this. 4x times 2 over x, we'll use distributive property here. We get 8x over x minus 4x over 4 in the numerator over, this remains the same, 4x times x minus 8. This just simplifies to 8 minus x over 4x times x minus 8. Okay, we still cannot use direct substitution. How do we turn 8 minus x into x minus 8? Let's just factor out a negative 1. This is equal to negative 1 times x minus 8 over 4x times x minus 8. Now, the x minus 8 cancels out. We are just left with negative 1 over 4x. And now we can use direct substitution. This gives us negative 1 over 4 times 8, which is equal to negative 1 over 32.